All right, let's see how you did on your obtaining a p-value and then interpreting that p-value problem. So here we go. On this first problem, we have that this is the proportion of the nation's children who show signs of autism, some form of autism. Make sure that it doesn't say showed. Make sure that it is not past tense. Okay, so we are speculating. We'll say, hey, let's start it off at the way that it has always been, and then, but we think perhaps it has increased over the 6%. So then when we put everything in there, and I think I had put 0.12, anyway, so instead of rounding, or I don't know exactly how, if you put more of the rounding, maybe I should have put 0.13. But anyway, so here we have this. So basically, regardless of exactly what you had gotten here, your z-score was somewhere around 5, so it's way out there. Okay, your sample is way far away from the null hypothesis. So I want you to look at a picture. It's actually I want to talk about the picture as we even talk about the interpretation. Your sample is way out here, 5 standard deviations above the hypothesized mean. This is where the data would be centered if the null was true. But you got something so far out there that you're probably going to suspect that the data isn't really centered here and is probably centered somewhere more like that. Okay, I don't know exactly where that is, but it's probably somewhere up there. So here we go. So if the p-value is the probability. So there's basically a 0% chance, and you can put these different colors in various orders. It doesn't matter. Just you can make it sound natural to you, but it needs to include these 3 components when you do the definition. That the p-value is the probability. So there's that percent chance of getting this sample or something more extreme if the null is true. So I have color coded it here. So the p-value is in red. So there's basically a 0% chance. And then of getting this sample or something more extreme, of getting a sample where 46 or more of the 384 children show some signs of autism, if the proportion of the nation's children who show some signs of autism is still at 6%. Okay, so then that makes me think it's probably not still at 6%. All right, here, this was an interesting problem because they were seeing if the complaints have decreased when actually the sample they got was a little higher. So that's unusual in how you handle this, but here we go. So P equals the proportion of this company's customers who have negative comments. So the proportion of the comments that are negative. So they first say that it's at 0.08, but they want to improve it. So they hope that that has gone down. So what happens is when you get your p-value, okay, and so this is interesting. This is the indicator, okay. So right here, the fact that the alternative hypothesis is less than, then that's why I got the p-value, the probability of the below 0.6. So whatever this sign is here indicates to you the area that you should be finding for your p-value, okay? All right, so that's 0.726. So that's right here. So see, look, the null hypothesis is that the negatives are at 0.08. Well, you got this sample right here even higher. So do we think there's evidence that this null hypothesis should be lower? No. If there's still 8% of customers' comments that are negative, so that's if the null is true, then there's a 72.6% chance of getting the sample we got, 31 or less negative comments out of the 350 customers. Okay? All right, so this is seeing the proportion of seeds that are still going to sprout after spending 1 year in storage. Remember we're supposed to have kind of like that treatment or the effect that we think that may be cause the issue that may be causing an effect, okay, in that parameter. So P equals the proportion of vegetable seeds who sprout or which sprout after 1 year in storage. So if they were fresh, then they would be sprouting at this rate, 92%. But they suspect that, does it say something? They think that they have lost their viability. That's why it is a less than 90.92. So once you put in all your data and you find your p-value, since it's less than, we're norm CDFing below that negative 3.16, so about 0. So let's look at here's what that looks like. So see this? Here's your sample all the way down here. This area to the left, there's basically nothing down there. There's a 0% chance of getting that sample or something more extreme if the data is really centered here around 0.92. So what does that say? I don't think it's really centered around 0.92. It's probably somewhere lower. And that's what we're going to actually lead into in the next lesson. So if the seeds that have been in storage for 1 year are still sprouting at a rate of 0.92 or 92%, then there's a 0% chance that I would have gotten a sample of 200 where 171 or less sprouted. So there's those 3 pieces to the p-value definition. All right. Now, with this number 4, make sure that you include this after the company's Super Bowl commercials have aired, because that is the treatment that we are testing to see if that has had an impact on the rate at which the company's brand name is recognized. Okay, so P equals the proportion of the public who recognize this company's brand name and associate it with computer equipment. And so, see, I got that. They want to investigate this. Okay. After the company's Super Bowl commercial has aired, because that's what we're testing. So we're going to take that and see what the recognition rate is after the Super Bowl commercials. Is it still at 40% or has it increased? All right, so we get this sample, and it does show a little bit more, 0.43, but is that an unusual sample or is that just sampling variability? So that was 1.25 standard deviations above the mean. I norm CDF above that. So take a look here. So if the data is centered around 0.40, then here's what it would look like. And see my sample here at that p hat there at 0.43. So there's a 10.56% chance of getting this sample or something more extreme if the data is centered there around 0.40. So what ends up happening is we'll in the next lesson say, I don't think that that's unusual. That could very much just be because of sampling variability. So I don't have a reason to reject that claim of it still being 0.40. All right, so here's the interpret the p-value. If the proportion of people who recognize the name brand and connect it to the equipment after the Super Bowl commercials has aired, so that's the null hypothesis, is still 40%, then there was a 10.56% chance of getting at least 181 out of the 420 adults who have that recognition. Okay. And I think this may be the last one. So this is studying the effects of acid rain on the Hopkins forest. So we're actually testing the Hopkins forest trees. So our P parameter is the proportion of the Hopkins forest trees that are susceptible to acid rain damage. And if the Hopkins forest trees are like the rest of the region, then it'll be 15% having that damage. But they're afraid that they are more susceptible to this acid rain damage. So we think it's greater than. So here, after we find our p-value, so I'm going to norm CDF greater than, and I get 0.0027, pretty low. So see this up here? There's my sample way up there. In fact, it's so far up there, I think it's probably not just regular old sampling variability. I betcha that somehow these samples are actually centered a little higher. That's where we're headed with this. So if the Hopkins forest damage rate is the same as the rest of the region at 15%, there was only a 0.27% chance that I would have gotten 25 or more trees of the 100 that have acid rain damage. Wow, that's a low probability. This p-value is that little probability of getting that sample or something more extreme if the data is centered around that 0.15. Okay, so I think that that's the last one, and then we'll go on into the understanding alpha and making a decision about a hypothesis test in our next lesson.